Okay. Uh, so in the last class, we were talking about recursion, right? Please listen carefully. Very important topic. In the last class, we have discussed about recursion, right? And we have taken the example of linear search for recursion, right? Just to repeat it quickly and to elaborate it more, easy way, I have just taken a screenshot of that code, right? Here is the screenshot of that code. I think it is visible, right? Now, assume ARR. Okay. Assume that. Why I'm not able to write here? A second, guys. Assume this array is. We have just taken the three elements, right? We have just taken the three elements. 2, 5, and 7, for example. Okay? 2, 5, and 7. Suppose we are looking for this 7 element as a key element, right? So when the main method calls this method linear search for the first time, right? It will pass ARR, comma, position is equal to 0, right? Comma, key is equal to, say, for example, 7, the last element, okay? Comma, n is equal to what? N is equal to 3, right? There are three elements. So this will be the call, right? The call enters here. The first base condition, position greater than n, is not met. It comes to the next base case, ARR of position. Position is what? 0. Is it equal to key? That is 7. Not met. Okay. So the code will proceed further. The code will proceed further, and here you will see that this internally calls itself with ARR, position is equal to 1, right? Guys, have you forgot the last session? The linear search with recursion. We have seen, right? Recursion means what? We keep on calling the same function again and again, right? By reducing the size of the problem. So initially the size of the problem was determined by the position. When position is 0, the size was n. The whole n from position 0 till nth element. That means n minus 1 index position has to be traversed, right? When in the next iteration, in the next call, in next recursion, guys, please remain silent. पीछे वाले please remain silent. When position becomes 1, right, we have reduced the size of the array from the 0th position to 1, 2 and -1, right? Rest of the things like key is equal to 7 will remain the same and n is equal to 4 will remain same. Now say this is the first recursive call. This is the first recursive call, right? The control will come to the beginning of the method. Position is equal to 1 this time. Position is greater than n, it is false. Position is equal to key, it is again false. It will again call linear search. Okay? With position is equal to what? This time it will again call with position is equal to this is the second call, right? This is the second call in circle. We have got same array, position is equal to 2 this time, right? And 7 is the search key, 4 is the size of the element. It will come back here. If position is equal to greater than n, no. Position is 2, n is 4, no. If array of position, yani element as index position 2, right? Is it equal to key? Is it true or false this time? No. There are 3 elements, right? So position is the index. Index means n minus 1. 3 minus 1 is 2. So at the third position you have got this 7. 7 is the key, right? 7 is the key. You have got the position this time, right? So after the second call, position will be returned. Okay? So it will be returned. So this is the return with position 2, and this return is for this call. When it comes back here, again there will be returned to this same position, and that will be returned for this first call, right? With the same value 2, that is the position value, index position. And from here it will be returning back all the way to the main method. Okay? Outside the function from where it is called, it will come to the main method with the same value 2, and 2 is the index position. Now main already has that array. Main will just print array 2, which is the 7, and print that this element is located at index position 2, right? Or 2 plus 1, yani nth location, right? Okay. This whole drawing is just meant to tell you that how the recursion, the way the recursion keeps on calling itself, the same way it unwinds itself. It travels back the same path. Okay. Correct? Yesterday we have tried to, in the last class, in fact not yesterday, we have tried to debug this problem also. Okay? And there we have seen that different calls happening and the variables changing, that video is uploaded, you must go through, right? The problem is that if you are not coming prepared with whatever has been taught earlier, then everything is going to be built upon the top of it, right? You will not be able to understand. Please come with preparation. Otherwise, it will be of no use. No matter how good the teacher is, how much effort it can put, if you are not cooperating, it will do nothing good. Okay? Next time, please come with preparation. Whatever has been taught earlier, that has to be prepared well. Okay? Now, the question is, in trivial linear search, how we were solving this problem? Using a loop, right? In trivial way, not with recursion. Earlier, we have seen the algorithm of linear search, and that was just traversing a loop, element by element, right? We just run a for loop from index position 0 to n minus 1, and we keep checking for a linear search. We keep checking for a linear search, right? If the element is found at any position, we just return the position. So everything was done within a single loop within the same function. No recursion, right? It was just a plain simple loop, correct? At least you have remember that part of the code or not? Simple linear search. Linear search कैसे करते हैं भाई? एक लूप चला रहे थे, फॉर लूप, राइट? की एलिमेंट ले रहे थे, आई एम जस्ट रिपीटिंग दैट, ठीक है? की एलिमेंट ले रहे थे और उसको एलिमेंट बाय एलिमेंट मैच कर रहे थे लूप में, ठीक है? बार बार लूप में वहीं पे आ रहा था, घूम के आ रहा था. व्हेन वी फिगर आउट दैट हियर इज द पोजीशन द एलिमेंट इज लोकेटेड इन द लूप at such and such traverse position, we just return that index position. That is how we did in linear search in a trivial way using a for loop, right? I have tried to solve the same problem of linear search with the technique of recursion, right? Recursion means calling the same function again and again. You can see once the linear search has been called by the main method, it will just reduce the size of the problem by incrementing the position plus 1, and then it will call it again, then call it again until that element is found or the array is traversed and nothing is found. Okay? Then it will start unwinding itself back, then again back, then it will go back to the main method from where it is initially called, right? This is what we have seen in the recursion. So tell me which was an easy way, the for loop or recursion? Recursion is easy. But think about it. I think you have forgot that linear search with for loop. Do you remember that? That was simply a single for loop in the same function. You start from index position 0, you search till index n minus 1, check for each element sequentially. Eh? It's not about time. Forget about time. Forget about time. Yes, recursion could be a little expensive because then the function call will wind itself and unwind itself, right? It could be little expensive, but that is very, very, such an expense that is negligible. I'm not worried about the time here, unless it's a huge task to do, right? I am worried about what is more easy to understand code, clarity. Of course, a loop, right? It's a simple, construct that allows you to iterate over elements, right? Correct? Here we have to imagine a lot of things, how the calls are being made and how the rewinding is done. I think most of the people have still not understood what is happening over here, right? So the first rule of development in any technology is that if you can write a simple, plain, simple, easy code, never try to write in a complicated way unless there is a need for it. Getting the idea? If you can write a code which is simple to understand, easy to read, okay, that's a very easy and readable code. It's not a logic that will confuse you, right? Always try to write with the simplest possible technique instead of getting the things messed up with a logic which is difficult to understand. Because if you are the developer and you left the company, someone else is going to manage your code. In 6 months of time, you must have done so much of work that you will yourself forget what you have done in the previous code. Okay? So that is the fundamental of good programming. No matter which language, which technology I am talking about, what you are doing. Okay? If something can be done simply, you do not have to use a technique which is difficult to understand or read. The code must be simple to understand. I have taken this example just to teach what a recursion is, but the point here is for linear search, the problem of linear search, this is not a right way to do it. Right? It's not a right technique to do it. ठीक है, करेक्ट. But there could be situation where it could be more useful. There could be situation where it could be more useful, right? ठीक है. So let's move to the next problem statement where it will make sense. ठीक है. अभी भाई लीनियर सर्च में आई एम जस्ट रिपीटिंग, ओके. अभी लीनियर सर्च में अगर हम सिंपली एक लूप से ये काम कर रहे होते तो ज़्यादा आसान होता ना भाई. तो हम क्यों इस माथा पच्ची में पढ़ रहे हैं, है ना. इतना कॉम्प्लेक्स कि हमें सोचना पड़ रहा है कहाँ से कॉल जा रही, कहाँ से कॉल अनवाइंड हो रही है ना. Moreover, if you try to debug a recursive code, debugging is very difficult. In a simple plain loop, there is nothing much to debug, right? If you stuck in a infinite loop, in a for loop or a while loop, you will just check the conditions. Did I miss any condition? Did I forget to increment? Right? That will be very easy to figure out where you have stuck in the loop infinitely. But in a recursion, it will be difficult. Okay? So all these conditions makes, if a technique looks very good, very exciting, doesn't mean that it suits your problem. So the decision has to make depending upon the problem, no matter which language or technology we are talking about. Okay? Let's move further. Let me close this. Let's talk about another problem. Now, even before we move to the problem, we have a quiz with 3 questions, and just try to understand that the restriction that nothing will work, these buttons will not work until you solve these 3 questions, right or wrong. But you have to solve it. Once you solve it, then only the page functionality will unlock for you. ठीक है, ठीक है. So the quiz is always based on the previous class that we have seen. So the previous class was recursion for linear search, right? Okay. So this is the quiz, a warm-up quiz. I will say it. In recursive function, what is the base case? We talked about base case. In linear search, we have written 2 base cases, right? Correct. So what is the base case? Look at the option. A case that call function again with a smaller problem, is that a base case? A simple case where we can give answer directly without calling again, is that a base case? Or the very first line of the program, is that a base case? Eh? Okay. He says C. What's your name? Abbas is saying C. Other opinions? In a recursion, what is the base case? Shall I show you the code again and then you can tell? There I have a commented base cases. Right? I want you to use your brain, please. This was the code. This was the code. Just look where, on what places I have written base cases. There are 2 base cases. So what are base case meant for? The first base case is what? This line. If position is greater than n, return -1. What does this mean? Sorry? It is out of the range of the array. We have traversed, we are not able to find the element, and we have reached out of the range, the last element. Okay? So we return index position -1. Because index position starts from 0, right? So we have written -1. So this is the first base case, right? That means at this point we know the answer that the element is not found. At least we know the answer, right? What is the second base case here? If we have actually found the element, so we are returning the index position. So either we have traversed and we have not found the element in the array, the array element is not in the array, or the element is in the array and we have indeed found out, right? So these 2 are the base cases. Okay. Now let's look back at the options again. Tell me now. अब्बास, अब बताओ फर्स्ट वाला. Abbas again says a case that calls a function again with a smaller problem. That is a call, that is not a base case. जहाँ पोजीशन को +1 कर देते हैं. Okay, let's try to figure out. तो पहला वाला है you say a case that calls the function again with a smaller problem, right? Others, any opinion? Second is a simple case where we can give answer directly without calling again. ठीक है? Let me open it again for you because I think there is a lot of confusion here. Just look at it. The first says the first option was what? The first option, a case that calls the function again with a smaller problem. So we are calling here with a smaller problem. Calling the function again with a smaller problem. This is not the base case. This is a recursive case, right? What are the base case? Here we know that element is not found in the array return index position -1. We are able to tell what the final solution at this point. Here we have found the key element. So we are again able to return the index position of the key element. So in these two cases, these are the base cases. So we are able to tell the answer at this stage, either at base 1 or at base 2. ठीक है ना? So the answer would be what? A simple case where we can give the answer directly without calling again. If I found that the element is not in the array, should I recursively call the array linear search again? No. If I found where the element is located, I will unwind myself, but I will not recursively call back again. Right? So the answer is a simple case where we can give the answer directly. Henry, clear? Is it clear or not? Clear? Okay. So this is the right answer. Next question. In our recursive linear search, which call used a smaller problem? These are the three calls. This was in the code. Tell me which call in the context of linear search, which call used a smaller problem? That means a recursive call is being made with a smaller problem, reducing the size of the problem. That is the whole idea, right? Which call? Tell me. See, right? This is in the code, right? This thing. Position +1. If position 0 means I have to traverse, if the size is 3, I have to traverse 3 elements. If position is 1, I have to traverse just 2 elements more. Because the size is reduced, right? So the answer is this one. Correct again? Next question. Which sentence, are you guys able to understand? Left hand side? समझ में आ रहा है? अभी क्वेश्चन पूछूंगा. Which sentence about recursion is true? True. It repeats forever without stopping. It calls itself again and again until it reaches the base case. It always runs faster. So Abbas says the second one. Tell me. Others, please. B. Who all says B? No idea? B. Okay. So we have seen in the code itself that the linear search method is being called by itself every time until a base case is reached. Then unwinding starts happening. Right? Correct? So Abbas is correct. It calls itself again and again until it reaches the base case. Right? So we have solved all the 3 questions, and then this next page is open. Now in this next page we will try to solve the problem of factorial. So what is a factorial? How to find a factorial? It's a mathematical problem, right? What is a factorial? You have to be a little bit louder. Okay, n factorial is n multiplied by n minus 1 factorial, right? Or we can say n factorial is a recursive multiplication. Like for example, if I talk about 4 factorial, just look at here. 4 factorial. So 4 factorial means 4 multiplied by 3 multiplied by 2 multiplied by 1. We will reach till 1. And then whatever is the product, which is 24, that is the answer. If I want to calculate 5 factorial, then 5 factorial is equal to 5 into 4 into 3 into 2 into 1, which should be 24 into 5. 24 into 5? 120. 120. Are you sure? No. कैलकुलेटर करो. 120 देखो है 24 into 5 है ना. अच्छा हाँ 125 से 5 कम. राइट करेक्ट. माई मिस्टेक, माई बैड. ठीक है, यू आर करेक्ट. अब कोई बड़ी वैल्यू को देके चेक करेंगे. ठीक है, he is correct. ठीक है. Okay, so you know what a factorial is, right? In short, what is this? 3 into 2 into 1, that is 3 factorial. If I would have asked what is 3 factorial, you would say 3 into 2 into 1. So 4 factorial means I can say 4 factorial is equal to 4 multiplied by 3 factorial, right? Right? Now what is this? 2 factorial. So I can also say 3 factorial is 3 multiplied by 2 factorial, right? Now what is this? I can say 2 multiplied by 1 factorial, right? For this part, right? 2 multiplied by 1 factorial. And how do we define by 1 factorial? Now 1 is left. How do we define 1 factorial? 1 multiplied by 0 factorial. And what is the 0 factorial? 0 factorial is defined mathematically to be 1. Okay? That is why 1 factorial is also 1. Now what is the base case here? If we try to solve this problem using recursion, what is going to be the base case? What is that we know where the next call will stop, where we know the answer? Sorry? 1 factorial, or rather we can say 0 factorial, because 0 factorial is indeed 0. From that 1 factorial is derived, right? So 0 factorial is what? Which is the base condition, right? Correct? Now look at this code, guys. Assume from main method, I am calling the function fact and pass value 4 to it, right? Correct? From main function, I have called fact 4. So I want to figure out the value of factorial 4. Here n becomes 4 when the first time this function is entered. Now base case is defined as 0 factorial, which is 1. So if this is 4 factorial, if this would have been 0, that means we wanted to find a 0 factorial, then we know that n is equal to 0, double equal to 0, then I will need to return back 1. The answer is 1, right? The answer is 1. For 0 factorial, the answer is 1. Correct? Now, so there is just one base case. No more base cases. In linear search, we have seen 2 base cases. Here it is just one base case is enough, sufficient. Now what I will do, I will say return n means, as of now n is 4, factorial of n minus 1 means 3. The call will come again here. Now this time n will become 3. It will enter here. It will enter into the same method. Is n is equal to 0? Base case is met or not? No. N is 3. It will come again. Return 3 multiplied by factorial of what? 2. Right? N was 3. So n minus 1 is 2. It will come again. Call itself again with the value 2. Now we are trying to find the factorial of 2. Is n is equal to 0? No, n is 2. I will proceed further. 2 multiplied by factorial of n minus 1, that is 1. It will come again, right here, with n is equal to 1. If n is equal to 0, no. I will come further. Return 1 multiplied by factorial 0, right? It will come again, so many times. It will come again. Now when it will come here, n is equal to 0. And the base case is met. N double equal to 0 becomes true, and it is going to return 1. So 1 is returned back to the first position where 1 multiplied by factorial 1 was called. So factorial 1 with factorial 0 was called. So factorial 0 will be replaced by 1. 1 multiplied by 1. So that 1 will be returned back to the same position where 2 multiplied by factorial 1 is called. Is with the value 1. So 2 multiplied by 1 is what? 2. Then the control will come back again in the previous call, right? Where 3 multiplied by factorial 2 is called. We know that factorial 2 is 2 as of now. So 3 multiplied by 2 becomes 6. Then the call will unwind itself once again. And this factorial 3 will be replaced by 6. And here it will be 4. 4 multiplied by 6 is 24. And then 24 is returned back to the main method as the answer. Right? Now imagine solving this problem with a loop. So here you will at least stuck with, you can solve the problem, but you will at least stuck with a nested loop, to a loop within loop. So that will not be a simple problem with a simple one loop. There also you will have to take care how you are going to reduce this value of n every time. Right? Now in that case, this factorial technique makes a better sense, because by the definition, the factorial of n is equal to n multiplied by factorial of n minus 1. This is the mathematical definition. Okay? Mathematical definition itself talks about the recursion. That is multiplying n with a problem of a smaller size by 1. Right? So it becomes very much obvious that this situation is the best fit for application of recursion. Getting the idea? You can try to solve it by loop also, and in fact you should do it on your own, right? But you will find that it will be a more difficult code that will be more difficult to understand even. Okay? Here the code is simple, just the mathematical definition. This mathematical definition is being applied 2 lines of code within one method. That's it. One is the base condition, one is the recursive case. Right? Guys, getting the idea? Now let me run it and show. So you can actually set different values here. You can try it for your own. As of now, I am assuming the same example. N is equal to 4, right? Okay. And let me start. Okay. I am manually doing it. You can play it also, but I am manually doing it with step over so that you can see line by line. Okay. So assume the main method calls the method factorial of 5, and the control comes for the first time here. So here it comes, right? Notice what happens. Here I have built a stack of calls to make you understand better. In the second example, guys, please listen. I have built a stack of calls to make you understand. So from the main method, the first function call will be factorial 4, right? Correct? इस लाइन को ध्यान रखिएगा. Just keep looking at this line, this stack. ठीक है? थोड़ा बड़ा कर दूं. ठीक है? Fine. So the first call is factorial 4 from main method. The controls moves. Tell me, does the base condition meets or not? No. And if 4, it is comparing with 0. Only 0 factorial is 1. It will move further. Now, as per the definition, 4 multiplied by factorial of 3. Now, it will call again this function with n is equal to 3. Now, let's see. See, this is the stack. That means from factorial 4 method, factorial 3 is being called. Okay? And in fact, to be very precise, the function calls are treated by the runtime or saved in the runtime in a stack data structure itself. When we keep on calling one function from the other, whether it's a recursive or from calling one function from the other, okay, and the statements within, so all these things in any language is being saved temporarily in the memory in a data structure that is called as a stack. You know what a stack is? You put one book over the other, over the other, over the other. That is a stack. And when you start removing the book, you will start removing from the top. Top goes first, second top goes first, and so on until the lowest or the first book that you have kept is removed. So this is the stack building. And once the whole stack will build, you will see how the stack unbuilds itself, or that unwinding I was talking about. So this will give you a clear picture. So I have entered into factorial 3. Let me move on. Is the base case is met? No. And is 3 not met? Unless n becomes 0, it will not met, right? Now what should this call? This means what? 3 multiplied by factorial of 2. So n becomes 2 this time. Step. Okay? N becomes 2. Somewhere below, I think I have also where? Just a second. See, you can see the recursive call. Number of call is 3 हो गए अब तक. Base case hit is 0. Depth, we have reached the depth of 3. So this is also, you can just keep looking. Anyways, so I will just focus on the most important part. So from factorial 3 method, factorial 2 method is called. Okay? Correct? Now, as we proceed further, is base case met? No. Base case is still false. We step further. What do you expect a call here? Factorial of 1. Right? Step factorial of 1 is called. Right? Let's move further. Is base case is met? No, it will met only for 0. Although we know that factorial 1 is 1. Right? But then we proceed further. Right? We could have done it for n is equal to 1 also. But we are strictly going as per the mathematical definition. That factorial 0 is 1. Right? Now, what will be the next call? Factorial of 0. So, we have reached to the depth of 5. And if we call the main method, then it will be the depth of 6. Right? So, that is the factorial 0 is called for the last time in the recursive call. We proceed further. Now, this base condition will met. And 1 will be returned. And that means unwinding will start. Coming back to this, right? Let's step further. Let's step further. Now, it is coming now. This time it will come back. See, it has returned 1, then return factor 2 1, right? Every time I keep on a step, it will remain on the same statement because from the same statement is coming back, right? See, factorial of 3, right? Then it will come back to factorial of 4, which is 24. Now this 24, when it will step over, this function will complete and the control will go to the main method from where we have called, and that is the client code. Got it? After returns back to the caller, and the caller is the same position. Like for the caller, for factorial 0 was factorial 1, so it returned 1 with factorial 1 with to the factorial 1. Then it returned back to factorial 2. When factorial 2 was called, that was 2 multiplied by factorial 1. So it multiplied 1 by 2. Then 2 is further returned to factorial 3. At factorial 3, it was 3 multiplied by factorial 2. So 2 was written, 3 multiplied by 2 is 6. Then it went back to factorial 4. Okay? That was 4 multiplied by factorial 3. So factorial 3 was 6. 6 was returned. 4 multiplied by 6 was 24. Got it? Any doubts? You can try with say a larger value, say let me say a 10 value, right? You can reduce the speed or increase the speed and just do a set and then play. It will automatically start playing. Yeah. You want to run the application with 0. Okay. Let's see. So let me just reset it. What Henry is asking, what if we start with 0? Return 0 क्यों नहीं कर रहे? Why we are not returning 0? Factorial of 0 is 1. Factorial of 0 is not 0. And if we return 0, eventually everything will unwind and it will be 0 because product means multiplied anything by 0 with 0. So factorial of 0 is 1 actually mathematically. Right? Was that your answer? Right, okay. If you want to see what happens if we try to find a factorial of 0, what will happen? Tell me. If we try to find a factorial with 0, factorial of 0, what will happen? Will there be a recursion? There will be no recursion. Let's just try step over. It will come with n is equal to 0, factorial of 0, right? It's just a simple method call. In first attempt only we got the base case, and then it will return back. It will return back to factorial 0 itself. So everything is over. If it would have been say 1, now what? The first call is factorial 1. Base case will not be met. Factorial 0 will be called. Now a stack is made of a recursive call. At least 2 calls are there. A max depth of 2 is reached, right? Step. Yeah. Once the base case has returned, there is a single base case, right? Only once in the lifetime of whole recursive call n will be equal to 0. The next time when it unwinds not at this position, it unwinds at this position. So that part is already skipped. So I will never go to that code back. And from here, I will return back here for the next iteration. Okay? Try to understand, call is being happening from this line number 7 itself. So when unwind happens, let it be 100 times, it will be from line number 7 to the next line number 7 of the previous call. Getting the idea? ठीक है? Hmm? He is asking, Abbas is asking, do we have to, in exam, right? Exam, do we have to show this stack? Maybe, if the examiner asks you. If he asks you to show all the steps, of course, he will not give you a large value. He will give you with 3, 4, factorial of 3 or 4, something of 5 maximum, right? Then you can show the stack. If the examiner asks, okay? Because in many competitive exams, a very normal question is, what is the going to be the max depth for this recursive call? And not only just that, you can think over and write on the copy and check for that. There are mathematical ways also to figure it out. Okay, you can just Google it. Eh? I can just ask anything, but in fact, I will not be making the paper. No, very very clearly, I will not be making the paper. Someone else will make the paper for this subject. So you are bare hands with only the knowledge. Okay, just like when you go outside the university. Okay, only your concept is going to help you. Whatever I am teaching you, that may help you. Don't expect that I am going to make the paper. The paper someone else will make. I don't know who will make. It may come from outside the university, but for sure I will not make the paper. Okay? See, if the question says just give me the code, okay, or explain in your ways, so you have just explained and not shown the stack, it's up to you. Why will someone cut your marks when that's not specifically asked in the question? Okay? If I am specifically asking that show me the stack also, or how the recursive call happens, then you will probably need to show this. Okay? And that is why I did not try to build the stack in the first question because it was difficult over there, but here it is easy to visualize after so much discussion. So that is why in this particular example I have built the stack also at the right side, so that when you try to practice, you can relate it whatever has been taught in the class. Okay, guys, there is no shortcut. You have to see all the videos again and again. And let me tell you very frankly, no matter what content you are referring to, it is not going to teach you this way, which can make things transparent to look into how things are working. Okay, this is a professional content. You are getting it just because you are my student. Okay, this is my personal professional content. Okay, guys, आगे बढ़े. Shall we proceed? Okay, now I have got just one more example of factorial, and that is binary search. Just like we did linear search, it's a problem of binary search, right? But I will not discuss it today because I think unless you revise it, it doesn't make sense because you have already forgot the linear search example. So I will upload the lecture today itself. You are going to watch it today. Both the lectures, previous lecture and this lecture, the last two lectures. This one I will upload and the previous lecture. You will go through it very clearly any number of times, but come with clear picture in mind. Okay? But we will at least solve this quiz. Okay? This quiz is on recursion for the problem of factorial. Okay? Now tell me, in our recursive factorial function, fact n, what value does fact 0 return? That is the base case, right? 1, correct? Perfect. Okay, next question. Which equation describe the recursive step for factorial? Which equation? Now this is the mathematical equation. First, second, or third? Second, of course, right? Factorial 4 is equal to 4 multiplied by 3, right? Second one, correct. And you are going to replace exactly the formula into your function call. That is the fun part, right? If we call factorial 3, how many times the fact called in total, including the base case? Forget about the main method. If we just call factorial 3, 6. If we call fact 3, how many times this fact function is called in total, including the base case? Okay, for 3, that is the first call. 3 will call 3 will call 2 factorial, 2 factorial will call 1 factorial, 1 factorial will call 0 factorial, and that is the base case. So how many times? 4 times. Correct? Okay. With this we have unlocked it, but we will see it in the next class. Okay? हाँ बताओ. आ सकता है. See again, Abbas has a question that maybe in exam I can give you to find the value of factorial n, right? Or linear search, and I can ask you to solve it using a loop as well as recursion. And in that case, definitely I will be looking upon the comparison, right? The comparison that we discussed. Okay, for a linear search, loop is more easy to understand, okay, more easy to debug, that is more readable code, okay. In recursion, things become difficult, right? Okay. In recursion, there is a function call to the same function call again and again, whereas in loop there is just one function call and everything is done in the same function call. Such contrast, maybe such contrast may be asked, right? Correct. I may ask, for this particular problem, tell me which method is more suitable, whether I should go with a loop or whether I should go with a recursion. Okay? So you will have to give a justification. Okay? Therefore, ultimately, it is how you train your brain to think. That is what is required for any profession. For any profession. Okay? If you want to be a great developer, you have to train your mind to think how you can write a great code, not just code. Okay? You are not supposed to fit a problem into a technique which is not natural to it. If something fits, it fits naturally. But try to solve it for factorial n. You are moving to nested loop, and nested loop is also complicated. That means you are reducing the size, so it will become. Try to code it, and you will see. Here, in recursion, in the factorial method, you have just written 2 lines of code. One is for the base condition, the other is the recursive case. Just 2 lines of code, and that is totally based on the mathematical function that could be easily identified what is being done over here. Okay. When you are able to see everything, of course, if you are solving a mathematical problem, I will assume you to understand the mathematics, right? Correct? And it is obvious there. If I ask it, if I force you that, okay, solve the problem of linear search with factorial, then you have to write it. Then I'm more focused about knowing that whether you know recursion or not, how recursion to apply the recursion, you know it this thing or not, right? Okay, any more questions? So I will upload this lecture today. Please go through this lecture and the previous lecture before coming to the next class. Okay?